Hi everyone, today I would like to share a solution for determination of deflection at selected joint of truss system using visual work method. I hope you're happy to learn this topic. Okay, learning is about sacrifice, and in the end we want something good for us and benefit for us and those around us. Please enjoy learning so that we are happy to learn something. Now turn back to this example where we need to identify the vertical deflection at joint E. Okay, vertical deflection at joint E of this truss using the visual work method. Visual work method. Given the Young modulus is 200 gigapascal, and the area for each member is 2000 square millimeter. The symmetrical truss system is loaded with two horizontal loads of 15 kilonewton at F and another 15 kilonewton at D respectively. Some of the members are loaded with uniformly distributed load of 16 kilonewton per meter at certain distance as shown in this figure. The truss is supported by pin support at A and roller support at C. When we talk about visual work method, this formula can be used when deflection, so deflection equal to sum of n small n L over AE. Capital N is member forces due to rear load applied to this truss. Small n is member forces due to visual load. The visual load of 1.0 is used for this solution. Okay, L is length for each member. A and E is based on these two values. Okay. If you look at this joint, if you look at this UDL or this uniformly distributed load, we need to transfer this load at point load to joints, both joints. Let's say for this member, we need to transfer this 16 kilonewton as point load to joint A and joint B. Okay, and this one also transfer to this joint and to this joint. This is value at joint A, joint B and joint C from this UDL, and I will show you how to transfer load to joint in other video, so you can refer to other video. Okay, now I will when we talk about visual work method, I prefer to divide into two parts. Okay, into two parts. The first part is solution for rear load due to rear load or identification of capital N, and this one is for visual load. Another part for visual load, small n. Okay, for rear load, we need to show all loads applied to this truss system. Okay, so I transfer to this one. Okay, like this. I hope you can see. Okay, very small, quite small, so I think I erase this one. Just concentrate to rear load only. Okay, this one. Okay, rear load. Firstly is rear load to identify capital N. Okay, for the first step is to calculate the support reaction. When you refer to this support A, it is a pin support. It has two reaction VA and HA, it has vertical reaction and horizontal reaction. Meanwhile, at C, we have only one reaction of VC, vertical reaction at C. Now, in order to calculate all reaction, we can use all equilibrium equation. In this case, we have three types of equilibrium equation: moment equilibrium equation, clockwise direction considered as positive, second is vertical equilibrium equation, and third is horizontal equilibrium equation. Now, for the first calculation, we use moment equilibrium equation, or we take moment at A equal to 0. So, if we take moment, we consider moment at A equal to 0, we can directly identify vertical reaction at C. So, now we look at this load, 15 kilonewton at joint F. This load will rotate clockwise direction to joint A. So 15 times vertical distance from F to A of 3 meters. And then we must consider this point load at B. This one will rotate in clockwise direction, 21.34 times 3 meters. And then we have this kind of load. This load will rotate in anti-clockwise to joint A. So this one becomes negative 15 times the vertical distance from D to A of 3 meters. And then we have this load, 21.33 kilonewton, okay, plus 21.33 times 6 meters minus vertical reaction at C, this one, okay, minus VC times 6 meters. So VC equal to 32 kilonewton. Next is we use vertical equilibrium equation for determination of vertical reaction at A. So going up, in this case, all loads directed upward direction considered as positive and downward direction considered as negative. So VA plus VC minus 21.33 at joint A minus 21.34 at joint B and minus 21.33 at joint C. So VA equal to 31.99 kilonewton. And finally is we want to identify horizontal reaction at A. So in this case, we have only three component or element that related with that in X direction, 15 kilonewton at F, 15 kilonewton at D, and HA. So equal to HA. In this case, rightward direction considered as positive. HA is rightward direction, so it is positive. And then 15 kilonewton at F, also rightward direction. And then 15 kilonewton at the leftward direction. So negative plus 15 kilonewton at F minus 15 kilonewton at D. So HA equal to 0 kilonewton. After we identify all reaction at supports, we go for determination. We go for the second step is to calculate member forces. Okay, member forces using the method of section and the method of joint. We combine these two methods. Okay, the method of sections and the method of joint. Okay, for the method of section, this one is the free body diagram for this section. In this case, I cut at this section okay, I cut this part, okay. It means that you can identify, when you cut at this part, you can identify three internal forces, three member forces. The first one is FFE or NFE, second NFB, third NAB. Okay, so this one is the free body diagram for this rear load, and we need to show all loads applied to this section or this truss at this part. So we have 31.99 kilonewton for VA and 0 kilonewton at A. So we can ignore this HA value. Okay, and then firstly, we need to identify theta or angle. This theta I consider as theta 1. For theta 1, or it is located at this position, okay, this one is considered as theta 1. Okay, theta 1 using tangent theta 1 equal to, okay, so this one is 1 meter, this one 1 meter. Theta, tangent theta 1 is 1 over 1 equal to 1. So theta 1 equal to tangent inverse 1 equal to 45 degree. So in this case, theta 1 is 45 degree. Now I want to identify theta 2. Theta 2 is located this one I consider as theta 2. For theta 2, tangent theta 2 equal to y height for this triangle is 3 meter, 3 and over 1. So theta 2 is tangent inverse 3. So the value is 71.565 degree. Okay, so theta 1 is 45 degree. So this one 45 degree. So theta 2 is 71.565 degree. Okay, using the method of now I want to take, or we can choose joint F, moment at F equal to 0. So if we choose joint F, okay, or we take moment at F equal to 0, automatically NFB and NFE equal to 0 are we not considered in this calculation, or we not considered in the construction of moment equation. Okay, now we go for the first, this one, this load reaction at A, vertical reaction at A. This vertical reaction at A will rotate in clockwise direction. So 31.99 times 2 meter, and then this load 21.33 will rotate anti-clockwise to joint F. Okay, rotate in anti-clockwise. So if anti-clockwise, the sign is negative 21.33, and the distance is this one, horizontal distance, from A to F, so 2 meter. And then we have this force NAB. This NAB will rotate anti-clockwise to joint F, so minus NAB times vertical distance from A to F of 3 meter. So NAB become 7.107 kilonewton. Okay, next. Okay, I prefer to take moment at B equal to 0. So if we take moment at B equal to 0, this force, okay, this one is joint B. So NFB and NAB will not included in construction of this equation. Okay, so equal to, now we consider this point load at F. This one will rotate in clockwise direction. Okay, so clockwise direction, so 15 kilonewton times vertical distance from F to B of 3 meter. And then we have this 21.33. This one will rotate anti-clockwise. So negative 21.33 times 3 meter. Horizontal distance from A to B is 3 meter. And then we have 31.99 kilonewton. This VA will rotate clockwise direction to joint B. So plus 31.99 times horizontal distance from A to B, 3 meter. And this load, okay, since NFE is an inclined force, okay, so we must consider this inclined force as horizontal component and vertical component. Okay, this one is NFE. For the horizontal component, it becomes NFE cos 45 degree. Meanwhile, for vertical component, it becomes NFE sine 45 degree. So now firstly we take this horizontal component. This horizontal component will rotate in clockwise direction to joint B. So it is positive and FE cos 45 times vertical distance from F to B, 3 meter. Meanwhile, for the horizontal component, okay, this horizontal component will rotate anti-clockwise to joint B. Okay, so negative NFE sine 45 times horizontal distance from F to B, 1 meter. And then NFE equal to negative 54.43 kilonewton. And finally, I want to calculate NFB. Okay, so this one, NFB. For NFB, okay, so I prefer to use vertical equilibrium equation. So equal to, equal to, since NFB is downward directions, okay, for the y-axis, okay, for vertical component, NFB become negative, and NFB sine theta 2, in this case theta 2 is 71.565 degree times no time. Okay, that's it's already kilonewton. So negative NFB sine 71.565 minus 21.33 at A plus 31.99 at A. So minus NFE sine 45 degree. So we have 4 components in this equation, or 4 items in this equation. So NFB is 96.77 kilonewton when we substitute this value into this equation. So in this case, we just calculate these 3 loads. Okay, firstly is NFE, these 3 member forces, okay, or force, internal force for member FE, FB, and AB. Now we need to identify this one and also this one. In order to calculate NAF and BE, we can use vertical, we can use the method of join. So we choose join. Okay, so we choose join A. So we need to draw the free body diagram. So it has 31.99 kilonewton for VA. Okay, so this one is NAB, and this one is FAF. So we refer to this part FAF. So not FAF, NAF, sorry again. And this one is 21.33 kilonewton. And we need to identify angle at this point. So we assume that this one is theta 3. Okay, so we need to identify theta 3. So theta 3 or tangent theta 3 equal to 3 over 2. Okay, vertical distance is 3 and the horizontal distance is 2. So 3 over 2. So theta 3 equal to 56.31 degree. So we use vertical equilibrium equation to solve this internal force. Okay, Fv going up positive equal to 0, so equal to 31.99 minus 21.33 plus NAF sine theta 3 or sine 56.31 degree. And NAF, force for member AF become negative 12.812 kilonewton. Lastly is joint E. Okay, so joint E, I prefer to refer to this joint because it has only 3 members, member AD, member FE, and member EB. Okay, for your information, in this case, member FE equal to force for member FE equal to force for member ED, force for member FB equal to force for member BD. Okay, so in this case, F okay, NAF equal to NDC, NAB equal to NCB, and then NFB equal to NBD, and FE equal to NDE. What else? 1, 2, 3, 4. 1, 2, 3, 4. Okay. So in this case, NFE and NFE is negative 54.43 kilonewton. So F and FD and ED also the same value. So now turn to this joint. Okay, so this one is NEB because we want to identify force for member AD. So this one is NED and this one is NEF. Okay, now we need to identify theta 4. So in this case, theta 4 is 45 degree, or tangent theta 4 equal to 1 over 1. So theta 4 become 45 degree. So we use force about vertical axis, equal to NEF sine 45 degree plus NED sine 45 degree minus NEB. Oh, sorry. So minus NEB. So equal to NEB here. So NEF is negative 54 46.43 sine 45, okay, plus negative 54.43 sine 45 degree. So NEB become negative 76.976 kilonewton. Okay, we just calculate all member forces or force for each member of this truss based on the real load. Now we want to identify member forces due to virtual load. Okay, so due to virtual load. Okay, this one. Okay, virtual load. Okay, now we put 1 point here, 1.0 or 1.0 here at joint E, because in this case we want to identify the vertical reaction, we want to identify vertical deflection at E. So first step, we go for the first step is calculation of the reaction. So VA and HA, this one is VC. So moment at A equal to 0. So equal to 1.0 times 3. This one will rotate clockwise direction to joint A. So, and then minus VC times 6 meter. So VC become 3 over 6 is 0.5 kilonewton. And then we use vertical equilibrium equation for determination of remaining reaction. VA plus VC minus 1.0. VA become 1 minus 0.5 is 0.5 kilonewton. And for horizontal reactions, so HA equal to 0 due to no horizontal load or no load applied at horizontal. So after that is second step is determination of internal force or member forces due to virtual load. Okay, force for each member. Okay, force for each member due to this 1.0. Okay, and then this is free body diagram. For we use the same step as real load. We in order to determine the internal force or force for each member, we use the method of section and the method of joint. Okay, now we choose for the first section. In this case, we want to identify this one, NFE, NFB, and NAB. So we use the same process or the same steps as real load for this one. So this one is 0.5 kilonewton. So we can ignore HA because the value is 0. Now we take moment. Okay, so angle, I want to, this one is 45 degree, and this one is 45 degree is 71.565 degree. So this one 45 and this one is 71.565 degree. Okay, so now we take moment at F equal to 0. So equal to 0.5 times 2 meter. Okay, 0.5, this one clockwise direction, rotating clockwise direction to join F. So the distance is 2 meter. A to F is 2 meter. And then minus NAB times vertical distance from A to F is 3 meter. So NAB equal to 0.33 kilonewton. Now we take a moment at B equal to 0. So equal to, okay, NFE cos 45 degree, okay, this one, and FE cos 45 degree, and this one for resultant from this inclined load as inclined member, inclined force, and FE sine 45 degree. Okay, so NFE cos 45 degree times 3 meter times 3 meter. Okay, so this one we rotate clockwise direction to join B, to join B, and then the distance is 3 meter from F to B, and then we have this NFE. Actually NFE is here, so this one will rotate anti-clockwise to join B. Okay, so negative and FE sine 45 degree, and the distance is 1 meter. And then for this 0.5 VA, so VA will rotate in clockwise direction, plus 0.5 times 3 meter. So NFE equal to 1.0615 kilonewton. And finally, I'm using vertical equilibrium equation for determination of NFB. So equal to negative and FE sine 45 degree, okay, for this one, okay, and then minus and FB sine 71.565 degree for this one on the y-axis, and then plus 0.5. So and FB equal to negative 0.264 kilonewton. And then we use joint A, the method of joint for solving another force, member forces. So let's say joint A. So we have VA 0.5, and then and AB, and this one is NEF, and theta here is 56.31 degree. So I'm using vertical equilibrium equation for identification of this force. So equal to NAF sine 56.31 plus 0.5, and AF equal to negative 0.6 kilonewton. Next we go to joint E. Okay, joint E. So this one is NED, this one NEF. We have 1.0 here, and this one is NEB. So NED is 1.0615, NEF the same value, 1.0615 kilonewton. This one also kilonewton. Okay, some reference, it is considered as unitless. Okay, so now we use vertical equilibrium equation. Okay, so FV equal to 0, so equal to 1.0 is downward direction, so it is negative 1.0 plus NED, okay, sine 45 degree for this one, and then plus NEF sine 45 degree for this one. Okay, so minus NEB, and then we substitute all values into this equation to determine NEB. So in this case, NEB becomes 0.5 kilonewton. Okay, 0.5 kilonewton. After we identify all member forces for real load and virtual load, okay, now we go for the next process of tabulation. Okay, for tabulation, I divide into several columns, 5 columns, 1, 2, 3, 4, 5 columns. The first column is for member. Second column is value for capital N due to real load. Okay. Okay, third column is N, small n due to virtual load. Third column is for length for each member. And finally is summation of N times capital N times small n times L. Okay, so we have 9 members, 1, 2, 3, so not really good. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, hopefully you could understand what I write. So like this. Now member AB, so AB equal to BC, and then AF equal to CD, and then FB equal to BD, and then FE equal to ED, and EB finally is EB. Okay, now we put all values into this table. AB 7.107 in tension or positive value. Sign positive means that the member in tension. Meanwhile, if negative, it means that the member in compression. So AF is negative 12.812. So CD also has the same value. FB is 96.77. BD is 96.77. FE is negative 54.43. ED is negative 54.43, the same value as ED. So finally is EB, the value is 76.976. And now we go for the virtual load. Okay, force due to this virtual load, 0.33 for NAB and BC, member force for member BC, both 0.33. Force for member AF is negative 0.6, CD also negative 0.6, and then force for member FB is negative 0.264, this one also 0.264, and then this one is 1.0615, this one 1.0615, and finally is 0.5. Now length for each member is 3 meter, 3 meter, 3.607. This one is 3.607, and then 3.16. This one 3.16, 1.414, 1.414. This one is 2 meter. Okay, and this one is 7.1, 7.1, 27.71, 27.71. This one is negative 80.73. Okay, and this one is negative 81.697. This one also 81.697. And finally is negative 76.976. Okay, sum for N, capital N and L equal to negative 332.21. Okay, now is identification of deflection, vertical deflection at joint E. So this one means that vertical, and this one is joint E, and this is deflection. What you want? Okay, the deflection. So turn back to the formula. So equal to sum, okay, VE equal to this one. Okay, A in this case is area for each member is 2000 square millimeter, so equivalent to 0.002 meter square. Meanwhile, for the Young modulus is 200 gigapascal, equal to 2 times 10 power of 11 Newton per square meter. So equal to, okay, delta VE, so equal to negative 332.21 times 10 power of 3 because of the kilonewton, okay, because of the kilonewton times 10 power of 3 over A, area is 0.002 in meter, in square meter times the Young modulus 2 times 10 power of 11, so equal to 8.3 times 10 minus 4 meter, so equal to 0.83 millimeter. And this is vertical deflection at E. The value is 0.83 millimeter. So now I want to wrap up. Okay, before we identify the deflection, so I want to remove this page, okay, this one too. Okay, the first step is calculate reactions. Okay, we go one by one. Now we focus on the real load. Okay, in order to use to use the method of section and the method of joint, the best way is we need to transfer load from UDL to point load. Okay, we change the load from UDL to point load and transfer the load to each joint. Okay, we need to calculate the reaction for real load and also the virtual load. And then second step is determination of the member forces. Determination of member forces, we can use the method of section and the method of joint. Okay, for the virtual load, we must bear in mind that, okay, 1.0, location of the 1.0 is depend on the questions. In this case, we need to identify the vertical deflection, so we change 1.0 like this. In vertical direction, going down or going up depends, but the different it will reflect to the value at the end. So in this case, 1.0 at joint E. So we calculate reaction, we calculate member forces using the method of section and the method of joint, and then we tabulate all the values into this table, and then based on this formula, using this formula, okay, so we can identify the deflection or vertical deflection at joint A. Okay, that's all from me. I hope you enjoy and you could understand what I try to share with all of you. Okay, bye.